Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. Did I just clip? I don't know. Anyway. By the way, if you guys aren't watching GDQ, AGDQ that is. I mean, I know right now you guys are watching me, and I greatly appreciate that. But if you guys aren't watching AGDQ otherwise, what are you even doing this week? Nothing of value as far as I'm concerned. This is episode 75. We are almost 3 years into my little streaming career. And almost 2 years into Rush to a Boy as a project. Which is nuts. And this is the 75th emulator stream that we've done. And I still can't believe that. I feel like I say that every time I start a stream lately, but still, it's crazy to me. We've mostly been working on stuff for the libretro front end of the emulator, and that's been going really well. Finished up serialization, at least with something that I'm moderately happy with last week. So stuff that's left on that, there's a lot of cleanup left to do. I would like to start working on profiling and improving performance throughout the entire emulator. That would be really, really nice. More cleanup. It'd be nice to get the core, especially the libretro core builds in CI, which would be really cool. I have a note on revisiting controller input and some other refactorings and supporting multiple stereo output options for like video output. So I think that stuff's really cool, and I really want to get to that stuff. However, I didn't feel like doing any of that today. Just how it goes sometimes. So what I thought I would do, I'm still bugged that Space Invaders doesn't work. And I still have no idea why. And I thought that we could spend some time maybe looking into that, or at least building tools to help us look into that. I could sit here and start reverse engineering the game code. We have enough of a debugger to be able to do that. However, that's really annoying. So I want to see if there's any way that we can get any sort of clue beyond that. Like I'd like to be able to, for example, look at what the video hardware is drawing in a more visual way. I think that might point us to some answers. Maybe, so, by the way, I'm going to show you guys what the bug is. That might help. I'm going a little slow today, and that's just how it is. This. Corpus Space Invaders. By the way, hi to guys in the chat. G. Superlin, Zao, Alkama, Mad Moose, Mr. Liquid, Wister Tobe, Daniel Collin. Happy New Year's, guys. Hey, Drew, too. Yeah, I'm looking forward to those too, Mr. Liquid. I'm working on a really, really long blog post about it right now. And when that's done, I want to release that. And hey, SKTS. I want to release that post, and then what I would actually like to do is schedule a couple streams where I go over that. And I could go over different parts of it and kind of elaborate more, and then maybe open up for some Q&A. I think that's kind of the best way to talk about that stuff. So I'm looking forward to that. Nice one, Graham. Hey, I said hey, SKTS, didn't I? I always forget. VRAM? Hell yeah, I've been watching GDQ. You must have just tuned in, because I totally ranted about that earlier. Hey, Pyro. Just going to hit my face on the mic a couple more times, and then I'll show you this bug. So I'm going to pause my music here and unmute my sound, because this bug is a lot easier to talk about with sound. I've shown this several times on the stream, I think. Yeah, I have GDQ on the background the entire week. GDQ is the highlights of my year, because it happens twice. So this is Space Invaders. I'm just going into like the default mode here, and we hit start enough times and we can play this. However, we start playing and you'll hear laser noises. And I can like move out and shoot lasers, but you don't see the lasers. And therein lies the problem. I don't know why that is at all. A couple places I suspect the bug might be is in the video hardware emulation, or perhaps the CPU emulation with bitstring ops. I have no idea. I think I tried running this game with bitstring ops disabled, or at least printing when they're used, and I don't think that was it, so no idea. So I think investing in some debugging tech might help us figure this out. I don't know. That's awesome, Drew, too. Your son should be both. Oh yeah, Mr. Liquid beat me to it. Yeah, I could call him away. I should just do that. Yeah, see, that's the other interesting thing I'll comment is that you do see parts of them. So, I don't know why. Daniel Collin, I did do quite extensive testing of the CPU, except I didn't cover FPU opcodes. So that might be it too, because I would like to go into like exception handling and stuff for those too. And I need to come up with a good way to test that. I also didn't test the bitstring ops. And I think those are the major areas I didn't cover. Everything else, though, I tested quite extensively by doing the fuzzing stuff. So there's still more places to look there. And I was thinking about bitstring in particular, because also memory loads and stores I didn't do. Okama, yeah, it might be the timing. I don't think it's going to be, or it might be timing. There's timing in the timer. I don't think it's going to be the timer in this case, even though I do want to debug that further too. Might be timing. I don't know. So here's what I'm actually hoping for, and I'm being a little hopeful here, but I'm hoping that I want to do some graphical debugging stuff, and I would like to get like a feature where I can like look at which different background layers are being drawn every frame, and for example, be able to like hover over one and then have it shown in like an outline over the viewport, like the extent of what's actually being drawn in that layer, because we can do that just by walking the tables in memory that the drawing hardware uses, and just pulling out the values from there. So I think that would be really nice, and hopefully that shows us something interesting. Maybe there's a little sprite that moves where the lasers aren't, and then we can see, oh, is the data on that sprite populated or not? If not, we can start looking into the code that might write to that memory. I don't know. There's a lot of things we can try. Worst case for this particular bug is that it just draws straight to the frame buffers, and then we might even have to debug in other emulators. So I don't know. I don't really know how we'll debug that further if that doesn't help us, but I know that this will be an interesting thing to have anyway. I started on this. Dale Collins says, do you plan to do some hardware versus EMU testing for this? Yes, actually. One of the things I would like to do with the fuzzing, I'll get to what I was talking about in a second, but one of the things I would like to do with the fuzzing setup that I did for CPU testing is, since that setup can read and write chunks of memory in both the emulator and on the hardware, like at the same time, what I can do is I can fuzz the video hardware as well, and write tests for that specifically, because I can write out the memory region that represents VRAM to like a known state, and then send over some code, have it be run, make sure that code like does some kind of drawing command and then waits, and then when that's done, then I can signal that it's done, and then I can go and read back the video memory. So, and I can like write straight into the tables that the drawing hardware uses. So essentially the command buffer. So I think something like that would be really cool. I would love to test that at some point. So I plan to do that at some point, but I don't know when. And maybe that uncovers relevant bugs. I don't know. But I'm looking forward to that. Madmoose says, does it work on other emulators? I actually haven't tried in a really long time. I probably should. I'm pretty sure it works on the hardware. I don't think I tested that either, but I can't assume that it wouldn't. Or I have a hard time assuming that it wouldn't. Hey, little bits. But yeah, what I was talking about before is I did start on some of this GUI debugging stuff. I don't remember when. Actually, I can do this. Check out this and get log. Last September. No, September 2017 even. So it's been over a year since I actually looked at that. I think I did a couple streams about this where like I just pulled in a tiny GUI framework I was working on just for fun, which I'll probably replace, but it doesn't really matter for now as long as we can get stuff on screen. Yeah, imagine having a broken ROM. You know, it might actually be smart for me to test this on the hardware before I move any further. I should probably do that. I might go get the Virtual Boy in a sec here. But yeah, I did start on this GUI debugger stuff, and I got it to where it was displaying VRAM at least, but not the rest of that stuff. So, yeah, I just kind of want to dig further into that. Before, I think I also did a stream where I optimized the VRAM display with SIMD. I would also like to update that code. I don't think I want to do that today, but like now that Rust has official SIMD support in the standard library, even if it's nightly only, I would like to use that instead of some library I used before. Anyway, what I would like to do is just update the code that we have minus the SIMD stuff, because that's actually on a separate branch anyway, which is nice. And then just start adding features to the GUI debugger. And I think that'll be more fun for me to work on today than libretro stuff right now. Anyway, I'm going to BRB because I'm going to grab the Virtual Boy and make sure that this is also broken on the hardware. Yeah, first I'm just going to transfer the ROM that I have over, and while I'm doing that, I'll plug everything in and stuff. Yeah, Daniel Cullen, all comment. I totally agree with you guys. Both of those things. All right, so where is that tool? Flash Boy. VBDE. Tools. ROM. I'm literally just clicking through a menu here. It's not very exciting. But since when did I care about that on my stream? Space Invaders. I might need to pad this actually. Yeah, I probably do. I'm gonna do that. Let's see. I don't remember how to use this tool again. Whoops, don't do that. No. Let's VBDE, tools, ROM. And then this should have pad. Yeah, the flasher tool isn't ideal. Oh no. That sucks, Graham. Let's see. What was this again? So we want to do the unpadded ROM and then the padding type and the size and the output. So this will be VRS Corpus Space Invaders VB, and we'll do the same thing. Or actually, wait a minute. Did I already do this? I did already do this. In May of 2017. You know, I bet I was looking at the intro of the game at that point. That's probably what that was. Hello, like Semtex. Yeah, I bet that was when I was debugging frame timing. Probably didn't even look at the actual game at that point. Anyway, this shouldn't take too long to test. I need to find the power adapter down here somewhere. Okay. Good. Yeah. That finished? Yeah, I did. Haven't you guys missed me staring into the Virtual Boy? Can you see the Virtual Boy? Probably not. You're gonna see me lean off to the side. That'll be good enough. Now it's a Ferris stream. Okay, it definitely works on the hardware. Yeah, I need to bring back the crotch cam too. Then you guys can see that I lost, what was it? 21 kilos in the last year. That is a real thing that happened. I'm good, Mad Moose, but thanks. Thanks, Mr. Liquid. Thanks, all you guys. Hey, Molliff. I totally looked more fluffy then. Now, long story short, he had to too, but it's way better because before that, people started telling me how fat I was, which was, if nothing else, a good catalyst for change. Let's put it that way. Also extremely annoying, but you know, what are you gonna do? It is. Move AX13H. Okay, anyway, this is a bug. That's good. Let's branch them out now. GUI Debugger again. Yeah, let's do that. I think if I build this, things don't work. Indeed they will, Alkama. I'll be just as cuddly. Perhaps a little less squishy. Yeah, I gained 3 kilos over Christmas, but I've lost 2 of them again, so we're good. And it was totally diet. I cut out an extra meal that I realized I was eating every day. And the rest is just eating more varied dinners and portion control. And the weight just fell off. Thanks, Drew, too. I can always count on you. Oh, man. You're welcome, Drew. Because those are both rad things. Yeah, let's actually get to what I'm trying to do here. I'm gonna rebase on master, and we're just gonna find all the problems. Bam. Oh, look at those conflicts. Oh, really? It's just the lock file? That's great, actually. That's ideal. Let's just do get reset head cargo.lock. Get checkout cargo.lock. And I'll just build this, and then we'll make sure we get the right lock file after I build it. Nice one, G Superland. No, I haven't seen the movie. Drew too. Definitely should. I don't think you want to tempt me. ASMR. And now we're going to wait for Rust to build the debugger. Dark Second, you came at the right time. Whispers borrow check errors. Warning. This was previously accepted by the compiler, but is being phased out. It will become a hard error in the 2018 edition. Okay, I'm done. I see an opportunity here. I'm glad you're relaxed. Yeah, I blame Mad Moose. It's okay, you caught the best parts of the stream, move away. Yeah, I got nothing on ScarJo. You know, and I don't know if the enemy lasers are supposed to make sound or not, because they seem to not either. Anyway, this was easy to get building. So that's great. Oops. I don't think there was much different here. Yeah, added wise guys dependency. Added this inspector thing. And just had that update with the virtual boy state every frame. That's perfect. And then that, I think, has everything in it, which is great. And that just, so it's mostly just adding a bunch of new code and basically nothing else. That's fantastic. Let's do that. And I'll force push that to that branch. That's fabulous. It's been a long time actually since I looked at the. Oh, you guys. I don't even think I showed you this last time. Hold up. Nobody heard that. I got the coolest thing for Christmas. The coolest thing. So I had the I had the official manual printed out for my own use in this big ugly binder and stuff. But someone for Christmas did this. Look at this. I don't know if you guys can see the words. Oh, no. Let's see. Well, I guess not. But anyway. This is pretty sick. This is Story of a Girl. No, this is the official manual in a really, really nicely bound book. Shout outs to my girlfriend Caroline for doing this. This was very special. And I'm definitely going to refer to this document today. Probably not in this form because it's annoying to use a book around the microphone. But I had to show that off because that's awesome. Anyway, the reason that's relevant is because we want to be looking at... I did that in CLI, didn't I? Yeah, of course I did. Good. I'm sure she'd be flattered you asked, Pyro. But I'm not sure she'd be into that. Anyway, what I was trying to show you guys earlier is there's some really nice notes in the beginning too, but I guess you couldn't see it on camera. Oh, well. It's with a K. You guys should follow her on Twitter, by the way. Spam. Posted that in chat. Anyway, hey, try later. So what I want to look at is we've got, if we just look at what we've got running here, I think this is RAM and this is VRAM is how I have that set up, and it just runs the emulator with in its own window and then runs this inspector thing in the other window. And what I would like to do is get another view. I was thinking to the right. It doesn't really matter though, where we can see some sort of visualization of, I think they're called windows in the Virtual Boy video hardware. I need to remember what that's called, but I want to, in particular, show like whether or not they're enabled or disabled, and maybe even like give the opportunity for a user to enable or disable those, because why not? And then also be able to draw like bounds and a couple other things. Mel says, why are there so many copies of the screen in RAM? It's not actually copies of the screen. You'll notice they're sideways. And this is basically the frame buffers in the Virtual Boy are sideways because of the way that the video hardware scans out the displays. So they're vertically, or I guess horizontally oriented rather than vertically. And so what you're seeing here is the fact that the stride of those vertical frame buffers doesn't quite align with the width of this display. So it's not that there's a bunch of copies, there's actually only two. There's the left frame buffer and the right frame buffer, but they're sideways and the stride doesn't match up to the width of this display. So it looks like there's a bunch of copies and they're all squished, but that's not actually what it is. Yeah, Con says 3 windows with mini FB. No, I think it's just the 2. I mean, I guess the 3rd if you count the console, but it's just the 2. Now I kind of want to try that Alcama. At least on a CRT. By the way, I really like this animation. They're really cute for an idle animation. Anyway, if I recall correctly, let's go into Virtual Boy Core, VIP mod, and in here, actually want to look at the mem map. This might be easier because I think you have up to 32 or something windows, and those can either be designated as like character backgrounds or sprites, I think. I really don't remember. The code should tell me. In particular, the drawing code would be the most relevant here. I think end drawing process is actually the function that does the drawing. Or maybe begin drawing process does. Begin drawing block, end drawing block, so draw current block. I think that's what actually does it, because it processes the screen by drawing them in vertical or in horizontal blocks. And each one of those is going to go through all these tables in particular. Oh, nice, Colin. Yeah, I use Mini FB a lot. Anyway, so it checks if we're actually drawing to the frame buffers, and then also calculates their offsets, because it needs to see like there's actually, so I had it wrong. There's not 2 frame buffers in VRAM. There's actually 4, because there's the left and the right, and then they're double buffered. So that's why there's sort of 4 rows here, and each one of those is going to represent one of these. And then I think there's some character memory interleaved before the final one here or something. I don't really remember. But there's those 4, and so we call those, like, I think it's left, right, and then you have the first set and the second set. Again, so it can be double buffered. So I think that's what this is doing, and then figuring out the offset into VRAM for where the actual frame buffers are. Or actually, it looks like it's left, right, looking at these offsets. That's fine. And I could see here, because this first one is 0 in hex, that, oh wait, there you go, sorry about that. I can see as well that because this first one is 0 in hex, that this top of this display is going to be the 0th byte, and then I think this is 256K of memory here, which makes sense because it's 64K RAM, and then that's 4 times the size of that. So here we clear the block, and you can see this just writes out to VRAM. So I think what was this doing? Column offset, and then this does 2 bytes for that. I don't remember the exact format. It doesn't really matter. And then there's some latching stuff here that should be correct for clearing the actual background color, because this actually uses the last one, and that latches the new value at the end of clearing the pixels for that block. So that's what this is emulating here. And then, okay, so there's 32 windows, and it starts from the last one and works its way back to the first one. So from 31 down to 0. And then, yeah, I've got a lot of like debug logging here. But then it reads this header, and then here we go. So here's the base, which is used to calculate the segment, and I don't remember what that is. Stop. So the stop thing is that you have, like, when you want to stop drawing, you either let it draw all 31 or all 32 windows, or you mark one as like a dummy window with a stop bit set, and then it will stop drawing. Overplane is, I think, whether or not when it reads out of bounds of the particular thing that you're drawing, whether or not it's going to like loop back to the beginning of that thing you're drawing, or if it's going to display a particular character throughout the rest of that. And that's, if you guys are familiar with Mode 7 on the SNES, it's the same idea. BG width and BG height, I think, is the width and height of the background as it's going to be drawn on screen, or maybe that's the width and height of, this looks like the segment. Maybe that's wrong. And this is, yeah, this must be the width and the height of the segment. I think it's windows mapped to segments, and segments are areas of the background maps. And I think they can be laid out in different ways. So I think you build like backgrounds out of segments, and I think this is how many segments wide and tall this will draw. Mode, I don't know what that does. Oh yeah, so you have normal, which is going to draw regular, and then you have line shift, which I think allows you to do similar to like changing scroll registers. Affine gives you something like mode 7, and OBJ gives you sprites for this background or for this window, and then whether or not it's enabled for the left and right displays. And then you have X and Y, which is the offset, I guess, in the frame buffers that's going to draw. Parallax determines the how much it's shifted. It shifts left for the left frame buffer and right for the right frame buffer or something, like positive and negative. I don't remember which exactly it does, but the idea is that it's that's actually how it creates the 3D effect, is it just shifts, just moves those one way for one eye and the other way for the other eye. BGX and BGY, I think, are offsets into the background. So that's why I think this is written the way it is that the a window is like a view into a background, which is a collection of segments. And so I think BGX and BGY are offsets into that segment, whereas X and Y are where it's actually going to draw in the frame buffer. I think that's what that is. And then width and height is how big that is. And I guess this adds 1. That can be important to know when we're drawing debug stuff. And then the parameter base, I think this is used, I mean, it must be used to read different params. I don't know what those mean though. Okay, so in here, I guess like the affine stuff is read from there. Line shift stuff is read. So I guess extra data is read from that offset. If used, and then the overplane character entry, which is which character it will actually use for overplane. I think that's just some remaining bits here. Yeah, it's actually the whole half word there. 16 bits. I think that's the parameters we care about for the window. So I guess the first thing that we might want to do here is do something to display what the states of the different windows are, or at least these headers. I'm not really sure how I might want to display this. I might even just display it as the header hex values to start out with. I think that's fine. I think this just does immediate mode drawing and stuff anyway, so we can basically do whatever. And I really don't mind hacking stuff together for this kind of debugger. Because it shouldn't get that complex. Like, worrying too much about scale for this kind of thing is just overkill, I think. And we just want to get stuff into this debugger kind of as quickly as possible for it to be useful at all. You know, I might even use like this area, and then I can just kind of display all of the textual parameters for a given window too, and then whether or not they're enabled or disabled. Maybe that's nice. It might be nice too to display stuff that changed in the same way that we do for the RAM here. I'm not entirely sure how I want that to work. So I might have some state between frames where it just keeps the current and last values for all these. Maybe. Not sure. But I think we can start just by drawing out the data. So I think I just used some hard-coded... I don't remember how this little GUI framework works either, but I don't think it does much. I think it just... you draw some stuff. Yeah, so I make this painter object for drawing here. Yeah, so just as a painter, and then it clears. Then we have VRAM view in this case. I think the reason why I keep the painter scoped like this is because it borrows the actual frame buffer, and then these just write into the frame buffer, I think. But we're gonna want to make a new painter then. I think this is a really cheap operation if I remember this correctly. In fact, I can just do it in here. And then the offsets here must just be hard-coded. Yeah, I have this little margin here. Yeah, I'll just hard-code offsets. I don't care. Let's see. And then I can draw like a rectangle like this. And we're going to want to do this something like that. And then I don't know what we need for this. So we'll go with that. I think this is fill color and fill and stroke. We can just go with this. Just start by drawing that. Okay, so that gets us something like this. Obviously, we're not going to fit 32 of those if they're that tall, but we'll just start adjusting this stuff to taste. I think I think this is the right way to do this, though. I think I actually also added like do lightest too, just to match the other stuff we did. This little GUI thing, I try to make it like as minimal as possible while still being generally useful. So like it uses paletted colors, and the palettes are from darkest to lightest. So there's only like 4 shades of color, and then you just kind of operate within that. And I think I also added like a stacking kind of thing that you could do, and you could draw like horizontal lines, vertical lines, basic text. You can make a button, and that will actually return a Boolean. So it has some really basic interaction logic that works with that. So like immediate mode, you just draw a button when you need that, and then it'll return a Boolean whether or not that is being pressed, which is okay. And then rectangles as well, and you can clear it, and that's pretty good. I think I could have sworn I added stuff. Or maybe I only started thinking about like some kind of layout thing. Maybe I didn't get that far, or maybe I just did that in the test. So I thought that I was working on that, but you know what? Now that I'm looking at this, yeah, no, I didn't. I just did some of the stuff by hand. That's actually perfect, because that makes this a little bit easier. We're going to do a little bit more stuff by hand, but at least the code's going to be really clear. So we can do something like this. Let mute window render y is 2d6 plus 4 plus 4. And then we can do this. And I think it clips all the drawing primitives too, so we don't have to worry about that. So now we can do for I in 0, 32. I don't care about hard-coded constants in this kind of stuff, or like magic numbers. Maybe this would be nice if we make a constant for this in the VIP module, just to name this, but at least these will never change. So that's nice. And then we can do window render y plus equals 16. We could do like let window render height is 16. And then we do this and this. And we can also do like let window render margin is 4. So let's do like that. Just run that. Yeah, there's a lot of these. I'll probably move this stuff around, but right now I don't really care. This is good enough for me. So I think also the margin stuff, I don't remember the semantics here. Yeah, so like the stroke happens around it. So this stuff is inclusive. So if we do like, let's see, we can just copy some code from the VIP2 that actually reads this stuff. Maybe that's easiest. So the window offset. I'm actually going to draw these in order, I think. Let's just start with this, though. We can do painter.text, and I think this takes X and Y, so we can do like this. Render Y, and then I think this is a string slice that it wants, so we can do in format, and then okay. There's no like clipping or dynamic shaping or like anything fancy in this little GUI thing, and that's okay. Okay, so apparently I'm rendering this window with some scaling turned on. So this is what this looks like. Probably just some margins and stuff, but we're not going to worry about that for now. And what I'm going to do before we do that is I'm going to go ahead and turn off the scaling for this window. Yeah, that's there. And then why don't I make this more better? Something like that. Yeah, so these need a lot of room. More better, less bad. One of those two. So I'm thinking 30s. This is what it would look like if we rendered all those down there. Let's actually move these over here. We can make them a little longer too. So that's really easy to do. Plus 512 plus window render margin. I think we can just do that, and then so then window render Y is actually going to be that. And then we'll make this wider by like So many. We'll add some more of this stuff. And some more of this stuff. Just hack this together until we get what we need. Which is just perfect. Almost. I like this. I'm actually going to make this a little taller even because I kind of want to make these a little taller. That's probably too much. Totally is, but not by that much. Actually, I don't really care if this isn't designed for actual screens. It's designed for me to inspect state. So it's okay if this doesn't line up with stuff. So the first thing I want to do is, I don't remember now if, I already forgot, if these are like active. I don't think you know that they're active until you see one with a stop bit, is actually how you're supposed to do that. So also window trips, and is this in the mem map here? Yes, which is great actually, because then what we can do is this. Boy core, VIP, mem map, like that. So I want to keep these alphabetical. Mem map is private. That doesn't need to be. Is this one private? That doesn't matter. We can solve that when we get to it. Looking good. I'm actually going to mute my sound, by the way, and play some music to make this more fun for me. Perfect. Then we're just going to copy some of the code to actually read this out, which is fine. For that, we'll do this. Whoops, where did that go? Did I close that? Didn't need to do that. Now this stuff can like change kind of at any time, but I think we'll just read them as they are whenever this is called. That's gonna be fine. And so we'll do this. I'll just copy this too. I don't care. can worry about cleaning stuff up later. And then now this like read VRAM half word function I think is not public. It wouldn't hurt to just make that public if it helps us out. So we're just going to do that. I don't think we ever need to read bytes. We might have to though, but we'll just do that. And then we can read this exactly like this code does, which is nice. So we'll do like this is and I'll do virtual boy. Yeah, that comes in here even. That's nice. So do virtual boy.interconnect.vip.readVRAM halfword at the window offset. And the VIP is private. That's okay. We can change that. I think I made a lot of this public. On the libretro branch. All of Word depends on the machine. In the case of the Virtual Boy, a word is 32 bits. And the fact that it's a word on like x86 is a historical artifact more than anything else, I think. Yeah, exactly what Mamu said. It's usually native bit width of the CPU. Anyway, we read it at least. So I'm just going to do this really quick here. It's a half word, so we just need 04x this, and then we can do header. This is an initial display. Not terribly useful to display it that way, but kind of cool to see this. However, I don't think you can tell already they're all the same, and that's not correct. I think we do the window offset here. Oh yeah, and then I mutate that, don't I? In the other one. So let's do this. Let's do window. Upside down Y? I don't know what you're talking about. Maybe we'll find out soon enough. Oh yeah, that's actually in the game. The upside down Y. Believe it or not. So I think the window. Yeah, I can do window attributes start here because we'll work our way up. I could also work my way down, rendering them backwards. Just maybe that's actually easiest. I'm actually going to do that. That's how we traverse it here anyway. And then this does not I, but window index. And then let's do this. Window render Y is plus window render height plus window render margin times 31. that. So I think then this, at the end of all this, it decrements the window index and the window offset. I think I like that. Because then what we can do too is, so this normally breaks when it finds a stop bit. We're not going to do that. We can do this though. So we can do, yeah, I'm not sure how we want to read this yet. We'll get there though. We can do let mute is enabled. And then we can, when we read a stop window, we'll do that. Hey, Darkstack. Yeah, Rust and first types. Yeah, we can always read these here. It really doesn't matter. But I'm thinking, because we can do like let is dummy is header is 0. And I'm thinking maybe I want to display if it's dummy here. Or like here. I always think it's kind of funny to do this, but something like this. If is dummy this, otherwise. One second, I'll be right back for a second. Yeah, we're back. So let's see, what was I doing? Yeah, this way you can render whether or not the window was dummy. We'll do that first. So we'll just do this. And then the other thing I actually want to do is this. We'll do, because I think we do color lightest on like all of this stuff. So let's do this. Let mute color is color lightest. And so then what we can do I think color is implemented as clone, which would make that, or copy, which would make that work. It should be. And then what we can do is I want to check this stop state. Because we can do window is enabled. And then we can do like if window. Actually, we'll do this even, which I think is even more clear. If window is enabled, then we're going to use the lightest color to render that. Otherwise, we'll do light. Oh. And then we're already displaying hopefully some useful information. But we can kind of build this out from here. Oh, whoops. We want to do this actually. Now that we're doing them backwards. And maybe I actually do want to flip how they're rendered because they're red top down, the red from the last one. Why does this say it's a dummy even though that clearly is not 0? I know why. Because I wrote this logic backwards. Whoops. I'm going to be right back for just a second again. Okay, that should fix that. And yeah, I actually do think that I'm gonna render these top down just because it should make it a little easier to read. Even though it's the opposite of the order when we look at the VRAM view, but I think that's okay. So then that's just that, which is good. Cool. So already this is cool. Because we can see some attributes here. I guess this hex 40 is the stop attribute. Here we have a couple different worlds. Here, actually, none of them are enabled, and that makes sense because if I recall correctly, this just renders straight into the frame buffers. So drawing hardware isn't actually used. Here, it probably is used for the rotation there. Here I have several worlds. Oh, this is really cool. Already we're getting useful stuff out of this. So I'm thrilled. Here's what I'm hoping we see. Maybe as we like shoot lasers or something, this changes. Probably doesn't, like the amount of them doesn't seem to change. But we still have a lot of stuff that we want to render from here. Like if it's rendering sprites, we might want to take a look at those. Probably also I'll implement like selection of these so we can kind of select one and then see more of its attributes in greater detail. I think that'll be good. It would also be interesting to like hover over these and see especially their bounds. Now I guess that would actually have to render in this view, which might be okay. I didn't realize the demo mode would just do this. That's nice. That's if you wait here. Yeah, maybe I'll do that, Daniel Collin. Just take a copy of the frame buffers. That's probably easiest. And probably the most helpful, actually. I'm going to do this, too. Status text is this. We can do if is dummy. And then we'll do the status text here. Also add the space here. And I actually want to do dummy and like parens or something. Because I want to do a couple other conditions here too. If stop. And then I would like to do like mode. So maybe actually mode text is what we want to call this. And then so this way this stuff kind of takes priority. Let's see. How do we map the mode here? I think we do this, which is nice. So I read the initial values here, and then I parse those into like window mode. Now this might be internal. I suspect it would be because I don't think they're used anywhere else. No problem in making those public. I suspect this other stuff will also, like object group and we also want to do. But anyway, now we can match this, which is cool. This is cool. So now we see like normal and stop, and then the other ones are dummies. Oh, I'm pleased with this already. And there we saw that with the rotating logo, it was a fine for a brief second. And here, these I think are fine too because these scale, so it's probably using those. That's so cool. Because you can kind of see their headers shift like this. I bet it's reordering those for like the priority for which one is drawn, or like the order in which these are drawn. That's really cool. And the stop, and you can see it probably just leaves some dummy data out here, which is why I wanted to kind of darken these ones that aren't used after the stop one, because I figured that like the state here isn't going to be read by any of the drawing hardware, so I figured that it would just leave some of that set. More affine backgrounds here. Here we have a lot of normal layers. Oh, there's a few that are fine. That might be really interesting. Maybe not. I don't know. I wouldn't be surprised if actually the reason these are fine is that like they represent different rows of enemies or something, and like the player, and then they use affine scaling to do like per line distortion, and that's how you get the perspective here. That would be a decent way to do that, I think. There's also an object layer here. Who knows what that's used for? But I guess we'll get to that. So I think what I want to do is maybe I want to move the display for these up, like this text up here, and then do like X and Y and width and height. Just display those as text at first. And then we'll slowly start making this a little more useful. And then I probably won't get much farther with this today. It's already been an hour and a half. But we can probably continue on this next week because I think this is fun now that we've actually started doing this. So yeah, so I'm just going to move this first. I'm also going to do 0.2 here just to make sure that always is displayed, and then we can do this plus 60. I don't know how wide this needs to be. We probably are going to make this a little wider too. So this is that window render width is 256 currently. Replace that. We might want to change that. I'm just going to tweak this by hand. Actually, I can figure out what this is supposed to be. 2, 3, 4, 5, 6, 7, 8, 9. 9 times 8 is 72, isn't it? So this would be plus 72, although I think I might want to do that, make that 80, because where I'm getting that from is that the width and the height of the characters, it's fixed width and height, and they're 8 pixels wide each, so do that. Another one of the sort of design constraints of this tiny GUI framework is that text should be fixed width, just because it makes stuff like this so much easier to do by hand. And you know, we actually don't need to write out the text header because I think it's kind of obvious. That's great. Okay, so now we'll do a couple things here. I think also while I'm at this, I'm gonna do let enter padding X for kind of annoying that this ends up propagating like this, but I don't really care. The code here does not need to be that pretty. Actually, the rectangle should not have the padding. And instead of 4, we can make this like 2. And then the heights of these, like 18. So it'll be like 2 lines plus some stuff. Or actually, let's do it this way. Let's go the other way, 24, 28. Having this stuff as magic numbers really doesn't matter when it's this quick to edit, because it just isn't that annoying. You know what, we can also, because that was a little too much, so let's actually do this and 1 and 1. That'll be maybe enough. Oops. So here, the next things I want to read out are width, height, X and Y. We'll start with X and Y, and I think, yeah, this is from the, yeah, it just keeps reading, because it reads the header, and then this is after the header. So we can do, we'll start with X, Y, and we'll probably skip parallax for now. So do I, yeah, it's the same kind of order. And then I don't adjust X and Y, so we'll go with that. And this is a whole half word. I don't know, I don't remember how much of that is valid. It reads the whole thing here, so I'm assuming at least for now, that we're just going to display the whole 16 bits. So we'll do X, Y. So make sure that these are actually displayed as hex. Then we can do X and Y. And then I wanted to add +8 here. And it didn't like something. Yeah, that's this. Whoops. Actually, that was what I wanted to do also. Okay. This in itself, I don't think will be particularly useful yet. And I think I also need to do 04x on these because they're half words, not bytes. So here we should see X and Y changing for these, which is awesome. Actually, it's just the X that changes because I guess all the scaling is done with the affine stuff. So you just see these rotate around, which is great. Okay, so here, see a lot of stuff moving around. Seems... I'm hoping some of these things will like represent the lasers. But what I'm guessing is that they represent these enemies here, because I think they update kind of in lockstep. There's 5 rows of these. We only really see 3 of these change. Maybe that's relevant. Does one of these move with the player? It doesn't look like it. That might be the object layer. So that's why we'd want like additional information to be displayed when we select one of these, so that we can like dig into the objects or the affine tables or something like that. I can't selectively disable them, but maybe I'll add that. Some kind of like override state in the VIP to enable us to do that. Diakon says, do sprites have a separate layer? No, any one of these windows, I think it's supposed to be at most one of them, but I think any of these can be designated as, so right now they're all normal backgrounds, but they can be designated as object backgrounds, and then the drawing hardware will draw sprites for that background, or for that window. So it's not like a separate layer outside of these, it's you designate one of these layers to be that, which is, I think, a really good way to do it, because then you can have a greater control over how this is composited. That's Q. Hey, Matt, RBA. Yeah, for now I'm just going to focus on continuing to pull state out of the stuff instead of like adding debug features to the emulator itself. I'm going to actually copy this whole block here. And we'll just comment out the parts we don't use it. I actually do want to display the parallax. So we'll add that here in a sec. And we'll not worry about those yet. So we'll do, for parallax, I'm going to do this exact same thing, except I'm going to add P for parallax. And then we can copy this and do 16 here, and we can add, I can remove this, and do width and height here. And I'm going to do W and H here just to keep everything compact and aligned, which is nice. Matt RVA says, do you ever get burned out with programming? Yes, I totally do. That's also why I like to make music or do Rubik's Cubes. It doesn't happen that often, and it usually lasts like a couple weeks, but I've gone months where that's a problem, and I've had to force myself to do anything. But I find that at least having lots of different kinds of projects really helps. So now I want to get back to this rotating menu because we can see the parallax will shift as these kind of shift perspective, I imagine. No, they actually don't. That's kind of funny. So that scaling is all 2D. Okay, this is actually really interesting and ideal. I noticed that this one here only ever moves when I fire a bullet. Oh, that's perfect. So I think window 21 is our player bullet, which is perfect. That's kind of cool. Why does it use line shift for that? Yeah, it should not change very much. Oh, this is perfect. So if we had a better display of the bounds that window 21 is drawing to when it draws its stuff, and if we could look at the memory it's drawing from and to, then we might be able to debug this really well. That's actually really exciting. I'm really happy to have noticed that already. Look at the invader moving. Cool. That's great that this is actually being useful. I'm going to cut off the stream for now, though, and we're going to continue this next week. But yeah, thanks guys for hanging out, and I'll see you next time.